ovarian cycle, the follicular phase and the luteal phase. Let's look at the corresponding events that are happening in the uterus, right? The uterine cycle. So the first two phases of the uterine cycle correspond with the first half of the ovarian cycle. So day 1 to 5 and day 6 to 14. Whereas the third phase rather of the uterine cycle corresponds to the second half of the ovarian cycle, which is day 15 to 28 or so. So let's look at the events of the uterine cycle that are taking place. So the first phase is called the menstrual phase of the uterine cycle. It's the shedding off of the uterine lining, it's decreasing blood flow, decreasing the size of the glands, and the sloughing off of the endometrial lining through the vagina, which we know to be the menstrual flow. This is triggered by decrease in estrogen and progesterone levels, again, because we have the degradation of that corpus luteum, because there's no fertilization, then we trigger this series of events that begins the sloughing off of the uterine lining, because there's no embryo that has implanted. So the corpus luteum begins to degenerate, and that is what triggers the menstrual phase here. That's day 1 to 5 typically. Now this can last a lot of different days. There's a lot of variability in the menstrual phase that can be genetic, that can be due to pathology, due to other natural causes. There are a lot of medications that can interrupt or prolong or delay the menstrual phase, but typically it's about 1 to 5 days. The second part of the uterine cycle is called the proliferative phase. And this is where we have the preparation of the uterus for a new fertilized ovum. We have development of the uterine lining, so thickening up of the uterine lining. We see the enlargement of the uterine glands, the glands that are helping to nourish the uterus. We see the thickening of the smooth muscle layer of the uterine lining as well, of the uterus as well. And we see the development of cervical glands that begin to secrete a lot more mucus. Now the triggers for this proliferative phase are estrogen mainly, which is being secreted from that developing follicle. So if you remember when we talked about the ovarian cycle 5 minutes ago, we said that the estrogen that's being secreted from the granulosa cell had two purposes. It's going to help the oocyte develop, but it's also going to be preparing the uterine lining. So this is what we were referring to. It's going to be stimulating or triggering the proliferative phase, which is the enlargement of the muscle, enlargement of the glands, the development of the blood vessels that are nourishing, bringing in more blood flow to the uterine, which helps to thicken it up. And then the production of mucus that will eventually create the mucus plug. Okay, all right. And then the secretory phase, which is days 15 to 28, is the last phase of the uterine cycle. This is where we have the uterine lining in its ripest stage, so to speak. So the endometrium is fully prepared for implantation at this point. So should a ruptured ovum become fertilized, and if we're correlating the ovarian cycle along with this, we know that this is after the rupturing of that ovum. So it is very likely that it could be fertilized at this time. And should it be fertilized, the uterine lining is well prepared for the implantation of that fertilized ovum. So we have the glands here that are secreting fluid. We have lots of blood supply, which is making the lining very thick. This is why the sloughing off of the menstrual flow is blood, right? That blood is what's really creating the thickening of the lining that's going to help to sustain the initial parts of that gestation. And then the endometrium itself is ripe for implantation. There's also the formation of the mucus plug. It's a sticky plug that is created by the cervical mucus that's being secreted from those glands. And that is to help to protect the uterine environment should implantation take place. So this is kind of the first, I want to say, immune defense of the embryo to help protect the environment in the uterus from any pathogens or toxins, bacteria that could be entering the uterine cavity beyond this point. And if we're looking at the kind of timeline here and we're looking at the thickness of the endometrium is pretty much the epithelium of the uterus, right? The lining of the uterus. If we see how the cells here have really thickened up, they go from becoming very short cuboidal cells to very tall columnar cells here. And they have much more blood flow. They have much more glands and glandular secretions. And you can see how it's much thicker here than it was at the final days of the menstrual phase when it has been completely sloughed off. Okay. So this is a very useful, very helpful kind of timeline here. And what we're seeing is day 1 to 28, so the full menstrual cycle, and we're able to compare the events in the ovaries, which is called the ovarian cycle, to the events in the uterus, which is called the uterine cycle. And we can see that the events that are happening at the beginning here, the follicular phase, are also corresponding to what's happening in the uterus, right? We're preparing a new ovum here, but we're also sloughing off the old endometrial lining and preparing a brand new lining should this ruptured ovum become fertilized in the second part of this cycle. All right, and then we have the granulosa cells secreting the estrogen in the first part of the cycle. Then the corpus luteum takes over the estrogen production, for the second half of the cycle. And then if it doesn't sustain, it's going to trigger the sloughing off, which starts a whole new cycle. All right, so it's really important to be able to compare what's happening in the uterus to what's happening with the follicle in the ovary. Okay, let's look at the hormones and the hormone changes during the cycle. So estrogen is secreted from the follicles during the first half of the cycle, and then the corpus luteum takes over during the second half, whereas progesterone is really a hormone of the second half of the cycle. There's not a lot of progesterone in the first half of the cycle. And if we think about the general functions of estrogen and progesterone, we kind of get a sense of why we see progesterone. Progesterone is really the pregnancy hormone. It's the hormone that if you look at its function, it's helping to prepare the uterine lining. It's helping to thicken up those glands as well. It's also the hormone that gives women those initial symptoms of pregnancy. So the nausea, the headaches, all of those pregnancy symptoms that we typically associate are being caused by excess progesterone, and it's really only peaking in the second half of the cycle. Other hormones involved are LH and FSH, luteinizing hormone and follicle stimulating hormone, and they are gradually rising and then they spike just before day 14. So the estrogen and progesterone that are otherwise inhibiting the secretion of LH and FSH, that becomes a positive feedback loop, and it actually surges right before ovulation. And the LH surge is actually what triggers ovulation. It's what triggers the rupturing of that ovum from the rest of the follicle, which happens around day 14. So let's look at the various parts of the uterine cycle here. We'll look at the early to mid follicular phase, and let's look at the feedback loops that are taking place. So whereas with the males, and I like to kind of point this out, but when we look at the males, we drew one feedback loop, right? We drew one feedback loop. There was LH, FSH stimulating the Sertoli cells, FSH stimulating the Sertoli cells, LH stimulating the Leydig cells, and that was just one series of events that was kind of always happening. In women, we have 3 different versions of this feedback loop. And that kind of just shows you the complexity of what's happening in female physiology compared to what's happening in male physiology with regards to the hormones. So in the early to mid follicular phase, we have GnRH. Remember, GnRH stands for gonadotropin releasing hormone, which is the hypothalamic tropic hormone. That is secreted, and it's going to trigger the anterior pituitary to secrete FSH and LH. Now, FSH is going to trigger inhibin, so much like the Sertoli cell, it's going to secrete inhibin, which has a negative feedback loop back onto the anterior pituitary. And it's also going to stimulate oogenesis and the development of the follicle, the development of the primordial follicles to eventually become a Graafian follicle. LH, on the other hand, is going to stimulate the theca cells. So the theca cells are going to secrete estrogen, and we can also compare the theca cells in some regard to the Leydig cells. These are the cells that are secreting the hormones that eventually have 3 roles. So the hormones that are being secreted, primarily estrogen, is going to have 3 functions, just like we saw in the males. 1, it's going to feed back onto the hypothalamus to inhibit GnRH secretion. 2, it's going to have a negative feedback loop onto the anterior pituitary to inhibit LH secretion. And 3, it's going to have a stimulatory effect to help with that follicular development. So much like what we saw with the Leydig cell secreting testosterone that had 3 similar roles. Okay, so this is what happens in the early to mid follicular phase. Okay, so we have the promotion of the endometrial growth, we have oogenesis and the follicular development. These are the actions of estrogen. It's also going to be responsible for increasing LH receptors on granulosa cells and helping to produce that LH surge which is required for ovulation. In the second half of the phase of the luteal phase, it's going to help with the kind of the more pregnancy-related functions. So this is in the case of fertilization. It's going to prepare the ductal tissue of the breast. It's going to help with prolactin secretion, again, preparing the breast, oxytocin receptors in the uterus, promotion of fluid retention. So these are the types of symptoms that we usually see in the beginning stages of pregnancy associated with the function of estrogen. Let's look at the late follicular phase. So the late follicular phase, again, we have GnRH secretion. This is right before ovulation. This is towards the end of the follicular phase, or if we're looking at the uterus, this is really the proliferative phase of the uterine cycle. We have GnRH secreted from the hypothalamus. That is going to trigger increased LH and FSH from the anterior pituitary. And then LSH and FSH will trigger the granulosa cells to increase the estrogen secretion. But instead of estrogen having a negative feedback loop on the hypothalamus, which is what we typically saw at the beginning, here it has a positive feedback relationship, and it's going to potentiate this cycle that's really what's going to cause the LH surge and then lead to ovulation. So at the late stage of the follicular phase in preparation for ovulation, the otherwise negative feedback relationship of estrogen onto the hypothalamus and anterior pituitary now becomes a positive feedback loop onto these 2 structures, which just temporarily potentiates the production of more and more estrogen, more and more LH, which leads to the LH surge, and that triggers ovulation. Okay, I hope that's clear, because that's usually an area that's kind of hard to visualize or understand. Okay, let's look at the functions or actions of progesterone. So progesterone, again, is the hormone of the second half of the menstrual cycle. We can think about this as the luteal phase of the ovarian cycle or the secretory phase of the uterine cycle. Okay, remember, we're looking at 2 different cycles. So here we have the promotion of the secretory phase of the uterine lining, so thickening up of the uterine lining, the glands, the mucus, the thickness of the muscle, etc. We also see growth of the glandular tissue of the breast and suppression of milk production that is in preparation for gestation. So these are some of the changes that progesterone kind of promotes. And although they're not listed here, it's also going to be responsible for the initial pregnancy symptoms like headaches, nausea, vomiting, etc., upset stomach, etc. These are the functions or the symptoms that are also corresponding to progesterone in the luteal and secretory phase. Okay. And then finally, the luteal phase here. So this is the third phase of the uterine cycle. So this is the third feedback loop that's happening here. GnRH stimulates FSH and LH, and now we return back to a negative feedback loop. So the FSH and LH that are being secreted are stimulating inhibin from the granulosa cell, estrogen, which is now coming from the corpus luteum. Remember, in the second half of the phase, the production of estrogen is kind of being taken over from the granulosa cell, now transferred to the corpus luteum, as well as progesterone, which is now also coming from the corpus luteum. And then these three hormones now have, once again, a negative feedback loop back onto the anterior pituitary to affect the decrease of FSH and LH, and back onto the hypothalamus to decrease GnRH secretion. Okay, so we start off with a negative feedback loop that is created by estrogen coming from the granulosa cell. And then we go to a positive feedback loop, which helps to trigger LH surge and trigger ovulation. And then towards the second half of the cycle, in the luteal or secretory phase of the uterine cycle, we then go back to a negative feedback loop. But here, the source of estrogen is different. It's coming from the corpus luteum, and then we also have progesterone added. Remember, progesterone was not around in the beginning in the follicular phase.